All right, in this diagram we are given that in the figure below, points K, A, and F lies on the same horizontal plane, which means this triangle over here is the horizontal plane, which means it is right flat on the ground. Now, TA represent a vertical tower. So TA is a vertical tower, which is this line over there is a vertical tower, which has to be perpendicular to the horizontal plane there. Then ATK is equal to x, so which is ATK, which is this angle, is equal to x, and angle KAF, which is this angle over there, is equal to 90 plus x, and this one, which is KFA, which is this angle over there, is equal to 2x. Now, it is given this restriction that our x that we're dealing with is right in the interval of 0 to 30. Now, then TK is equal to 2 units. So that's the information that we have in this diagram. Let's work it out. What is required? First of all, we are to find AK, which is this side over there, AK in terms of sine x. As you can see that this is the right angled triangle, KAT. This is the right angled triangle there, where A is a right angle. Now, you can then use the trig ratios, which is sine in this case, because sine this angle is equal to opposite over hypotenuse. So you are having sine x is equal to opposite is KF, KA, yes, KA, which is what we are looking for, or AK, divided by the hypotenuse, which is just 2. So AK in simple is just going to be 2 sine x. So AK can be represented in terms of sine x that way. So that is AK. So moving to number 2, calculate the numerical value of KF, which is we are looking for the numerical value of KF this side over there. So what is the required now? We have figured out that this side is 2 sine x, so we can use it anyway if needs be. Now we are looking for this side. What is it given there? I believe that we can also find something like what? So the idea here is to figure out what is this. If we can find this side as well, if we can find the side, how can we find this side? All right, so the idea here is to use the sine rule. What about sine rule? Because we are having this side and this angle, we have this angle and we are looking for that side. So let's use sine rule there, which means our sine rule will take us to sine this angle, which is sine 2x, divided by this side over there, which is the side that is opposite to this given angle, which is 2 sine x. So it is equal to, we're given now what? This is the angle that we have, this angle 90 plus x. We are going to be having sine 90 plus x, which is the angle, then divided by the side that we are looking for, which is KF. So for now we are right there having that one. So on that note, we can expand this one because this is a double angle of sine. So double angle of sine 2x can be given by sine 2 sine x cos x, then over 2 sine x over there. So then divided by, so you can see that this one you can reduce the using cofunctions. So sine 90 plus x, you are really talking about now this is going to be cos. Sine is positive on the second quadrant. This is just going to be cos x divided by kf. Wow, Now let's try to eliminate some things. This one can cancel that one because they are the same, and this one can also cancel this one because they are the same. And moving to our simplification, we are having, let's just do the cross multiplication there. So we're going to be having kf times cos x is equal to just cos x. So if you are looking for kf, you have to divide by cos x both sides. So our kf is now going to be just equal to 1. So we are having the numerical value of kf being just equal to 1. We have figured out that sine rule can really help us here because we do have these corresponding sides and corresponding angles for us to use effectively the rule of sine. So otherwise, if you have any comment about my presentation, how it's simplified, you can just comment down below and do some other advices on how to improve my presentation. Otherwise, see you right in the next video.